Okay, 1.7 is about the properties of real numbers. There's a few. There's five. Commutative, associative, distribution, or distributive, some people call, identity, and inverse. Commutative, well, let's think about commute. We hear in the news in the morning, the commute is fine. What commute means is to move. They're talking about cars moving, transportation, and everything. So, commute means to move. So, an example of commutative could be something like 3 plus 8 is equal to 8 plus 3. Notice how the 3 and the 8, they move. Like once again, commutative, that's what it means, to move. It could be addition, it could even be multiplication. Like 2 times 5 is the same thing as 5 times 2. Once again, commute means to move. Associative, you guys have heard the phrase guilty by association. Associative means grouping. For this one, let me do three numbers. I'm going to have 1 plus 2 plus 3, but I'm going to group up the 1 and the 2. And I'm going to say that is going to be equal to 1 plus 2 plus 3. Notice how the order of my numbers is the exact same thing. 1, 2, 3. It's just that in one side, I have a group, 1 and 2. On the other side, I have a different group. But the results should be the same. Like the order of the numbers is the same. It's just that on one side I have one group, on the other side I have another group. Now distribution or distributive, I'm gonna need a parentheses, and I could have inside like x plus 3, right? Just to have two things. It could be more than two, but I will have a number on the outside. Let's just say 5, just to do something. Distribution means to give to all evenly. So what I'm going to do, I'm going to multiply the 5 on the outside, I'm going to multiply to the numbers on the inside. X could be considered a number. I'm just going to multiply 5 times a letter. But remember, distribution or distributive means multiply the number on the outside to the things on the inside. So I'm going to go 5 times x, that's 5x, then my plus sign, and then 5 times 3, that is 15. Now, identity and inverse are very, very important. Identity, we're going to use those later on in chapter 2. Identity sounds like identical. What it means is what you begin with is what you're going to finish with. So if I'm doing addition, I'm going to go, for example, 9 plus 0 is equal to 9. Notice how my 9 at the end is very similar, in this case identical, to a number from the first operation. So in identity, anytime I add 0, I could go 5 plus 0, it's equal to 5. So adding 0 does nothing, so that's why we call it identity for identical. So in addition, I will be adding 0, but in multiplication, the multiplication that does nothing, and that's why it's important. Mathematics is very, very important. The number that does nothing in multiplication, it's 1. So I could go 9 times 1 equals 9. I could also go 5 times 1 equals 5. Notice how my result is very similar or identical to one of my numbers at the beginning. So in addition, you add 0, that's what identity is. And in multiplication, you multiply by 1. Remember, your number from the one number from the beginning is identical to your result. So that's why I call it identity. Inverse sounds like reverse. When we're dealing with addition, remember how I just said 0 is very important? When we're dealing with addition, I want two numbers that when they add up to 0. So the example could be 9 plus a negative 9. That is equal to 0. It could be 5 plus a negative 5. That's also equal to 0. So for inverse, if I'm dealing with addition or subtraction, obviously, addition, subtraction, I want them to equal to 0. The important thing for inverse is that I have the same number. You notice 9 and 9. It's just that they have different signs. Now, for inverse in multiplication, remember how the important number in multiplication is 1? I want my numbers to multiply and it is equal to 1. So I could have 9, let me me see, this thing just froze for a minute. While I'm waiting for it to unfreeze, just remember that in multiplication for the inverse, once again, it sounds like reverse. For my inverse, I'm looking for two numbers that multiplied equals 1. And the reason why it is 1, because that's the important number in multiplication. Wow, this thing really did freeze. Okay, so now that is back, I'm going to go 9 times 1 over 9. That happens to be 1. I could even go, let's change this to, instead of 5, let me go negative 5 times negative 1/5. If we multiply that, that is also equal to 1. Oops, I erased that. Let me bring it back. Negative 5 times a negative 1/5, it's equal to 1. Remember, I want it to equal to 1. The important thing in multiplication of my operation for inverse, I have the same number. It's just that notice I flipped my fraction. Because technically 9 is 9 over 1. So this one is 1 over 9. Technically this is negative 5. So this is negative 1 over 5. It's what we call the reciprocal. So that's the important thing. So alright, so now that we know the rules, let's take a look at a few questions. Use the commutative property to complete each statement. Remember, commutative means my numbers are going to move. So negative 8 plus 5 is the same thing as 5 plus, I'm going to write negative 8. Negative 2 times 7 is the same thing as 7 times negative 2. Remember, the numbers move. Now, my other example, use an associative property to complete each statement. 8 plus the quantity negative 1 plus 4 is equal to 8 plus negative 1, and then outside is plus 4. Notice how the order of my numbers are 8, 1, 4, so I should have 8, 1, 4. I should have the same operation. Here, 2 times negative 7 times 6 is equal to 2, and I'm going to do inside a bracket, I'm going to do negative 7 times 6. Notice how here on the left I was multiplying 2 times negative 7. Here I multiply negative 7 times 6. So the groups are different. That's what associative is. But notice how my order of the numbers is the same. 2, negative 7, 6. 2, negative 7, 6. We decide whether each statement is an example of commutative property, an associative property, or probably even both. Notice out here I have my order. Oh, let me take a look at the order of the numbers just to see if it's commutative. The order of my numbers is 2, 4, 5. Here I have 2, 4, 5. So the order did not switch, so it's not commutative. Now, on the left, I have a group 2 plus 4. On the right, I have a different group, so that is associative. Now here, in the inside of my group, I have 3 times 10. Notice I have 3 times 10. Here on the other side, I have 10 times 3, so my numbers did switch. So that's commutative. I have the same group, the number 3 and 10, just different orders. So the group is the same, so that's why I'm not going to call this associative. Now here, first let me see if the order of my number switches. 8, 1, 7, 8, 7, 1. So okay, so the order switch. So there's commutative, because the numbers did move. And then I look at my groups. Here I have 8 plus 1. Here I have a different group. So it's also associative. So I'm going to call this both. The commutative and associative property, you guys could be like, well, why are they so important? Um, they are important because they make it possible to choose pairs of numbers that are easy to add or multiply. For example, notice I have my colors, and you guys seen them in a white. Let's say I had 23 plus 41 plus 2 plus 9 plus 25. That sounds a little bit hard, but what if I combine, I'm going to move my numbers. What if I combine 23 plus 2? That's easy to call 25. Then what if I was to combine 41 plus 9? Now that's easy to combine. That's 50. And then I have a plus 25. Then we look at this, 25 plus 50 plus 25. All right, what if I was to combine 25 plus 25? That's 50 plus another 50. My number is 100, right? So it is easy to multiply. I mean to add. And my example B, let me do multiplication. It's easy since it's all multiplication. I can do 25 times 4. So we know that's 100. And 100 times 69, I'm going to call that 6900. One thing though, for commutative to work, if it's addition, subtraction, make sure they're all addition or subtraction. When it's multiplication, in order for commutative to work, make sure they're all multiplication, not division, multiplication. Make sure they're all multiplication, and then you can deal with um, commutative. So that's why they're important. It makes it easier to complete with, to work with. Now, use an identity to complete each statement. So 9 plus 0, I'm gonna use this is 9 because I'm using the identity property. Remember my result and a number from the beginning, they're identical. Now here, I have -7. I already have a -7 on the left. So I'm doing addition, and I know in addition, my important number is 0. And when I'm adding for identity, when I'm adding a 0, either at the end or at the beginning. When it's dealing with multiplication, I have to multiply by 1. So here, let me complete this as 5 times 1 equals 5. And one thing you guys will see also in this section is to simplify fractions. 49 over 35. There's two ways of how we can do this. One way that people come and say is divide, because we're trying to make it smaller. So divide top and bottom by the same thing. My case, let me divide each number by 7. So I know 49 divided by 7 is 7. 35 divided by 7 is 5. If you can still do another division, if you can divide top and bottom by another thing to make your numbers even smaller, then do so. But in this case, we cannot, so 7 over 5 is the same thing. Now, another way, because I said there's a couple ways of how to do this, another way, people come and say, look at 49. Think of two numbers that multiply equals 49. So I'm going to go 7 times 7. Then look at 35. Think of two numbers that multiply equals 35, but one of them should be the numbers on the top. So I'm going to think of 7 times 5. Cancel out those 7s because they're the same thing. So if you notice, I finish with 7 over 5. Whichever way you do, obviously, it's fine. Now, looking at addition, I know I have to have the same denominator. So the number at the bottom I can see is not the same. So I know 4 and 24, they can go into 24. So I can make the bottom 24. Notice I'm not changing my second fraction, so let me just put my 5 in there already. Now here, my 4, in order to become 24, I'm going to multiply this one by 6, right? Because 6 times 4 is 24. So let me multiply the top by 6 as well, so I get 18 over 24. Notice how when we simplify, we divide. Now here, since we're making the numbers bigger, we multiplied, but we still multiply top and bottom by the same thing. Now, in addition, on fractions, we want the bottom number to be the same thing because that way we copy it. Now on the top, 18 plus 5, that is 23. If you can simplify your fraction, do so. And what I mean with simplifying is what we did in example A. So if you can do so, in this case, we cannot. So just 23 over 24. Then use an inverse property to complete each statement. Remember, inverse, I said that in addition, the difference is that one of them is a positive, one of them is a negative, because that's how they add to 0. But in multiplication, they are reciprocals of each other. So what number plus 1/2 will equal to 0? I'm going to say -1/2. Remember, same number, just different signs. 4 plus something equals to 0. I'm going to complete this with -4. Same numbers, but different signs. Negative 0.75 plus 3 over 4th. Technically, they are the same number because 0.75 is 3/4. It's just that different signs. So I'm going to complete this obviously with a 0. Now here in multiplication, I wanted to multiply equals to 1. Remember, all I'm going to write on here is the reciprocal of this number. And the reciprocal, remember, I flipped my numbers. So instead of 5 over 2, I'm going to complete it with 2 over 5. Right? I did the reciprocal of it. Lastly, my last example for this lesson, oh, my second to last, we're going to use the distributive property. We're going to multiply the number on the outside to the terms on the inside. So first, 5 times 9 is 45. Then I have a plus sign. 5 times 6 is 30. I'm not going to combine. We can do 45 plus 30. We know that's 75. But I'm just going to leave it as 45 plus 30 because I just want to emphasize that on distributive, we multiply the number on the outside to the terms on the inside. Now here, 4, let me multiply it. 4 times x, it's just 4 plus x. 4x, plus 4 times 5, that's 20. Then there's a plus sign. 4 times y, that's 4 times y, so 4y. And that's pretty much it. Then my last example is also the distributive property, but it just says right without parentheses. When we see a negative sign in front of a parentheses, that's representing -1. So multiply the -1 to the terms on the inside, right? The negative sign by itself, that represents -1. Now, -1 times 2y, that's -2y. Remember, multiplications, if the signs are different, my answer is negative. -1 times +3, I'm going to call that -3. Same thing for my example B. Remember, this represents -1. -1 times -9, that's going to become positive 9w. Here, notice I'm going to call this +2, including the sign, just because the signs might change. So let me call this -1 times +2. Let me call this -2. I didn't call this a plus sign. I called it a positive sign just because I was afraid that signs might change, and that's basically what it happened. So good luck on your homework.